Welcome to the Celerative University Knowledge Exchange. In this series of science-based toolpaths, we're going to introduce you to the technology of Volumill. Volumill is developed by Celerative Technologies. It's not a standalone CAM application. Volumill is a science-based high-performance toolpath engine designed specifically for rough milling. Volumill is beneficial and profitable because it allows CNC programmers to use the most appropriate cutting styles and optimum speeds and feeds. That cannot be done with the toolpath shown here. This toolpath generated by Volumill contains no abrupt changes in direction or to the volume of material encountered. The load on the cutting tools and spindle never exceeds user-programmed limits. Consequently, machines run smoothly and tools run cooler, even at higher speeds and feeds, extending tool and machine life. As you can see in this simulation, Volumill's patented technology delivers smooth, flowing tool paths that never exceed your programmed rate of material removal. There are no abrupt turns or over-engagement at any time during your operation, making it a much more efficient method for removing bulk material. But simply adding Volumill to your CNC machining processes only goes so far. Without understanding the science behind Volumill, you may not be able to take advantage of all the benefits available with Volumill. The key to this science begins with maintaining a constant material removal rate throughout the entire rough milling operation. This is achieved with volumetric milling, where the volume of material being removed at any instant does not change. Understanding high-speed milling is also important when using Volumill. This is more than just simply running faster, but it's applying basic physics to tool stability and thermal stress. The mechanics of milling, particularly force and work, influence the speeds and feeds just as much as material and tooling. The mechanics of milling starts with chip formation that occurs during the milling process. Chips are the debris resulting from machining. Thicker chips result from heavier cuts, and they generate higher cutting forces. During chip formation, heat is generated from the dissipation of work. More work is done with higher cutting forces, and this generates more heat. The image to the right shows a chip being formed as the end mill rotates and feeds into the material. Let's take a closer look at the theory behind what's happening here. As the chip is forming, material shears along a theoretical plane. The area of this shear plane is proportional to the thickness of the chip. This work done to form the chip generates heat, primarily due to plastic deformation, and to a smaller scale, friction. Understanding the mechanics of milling will help you optimize speeds and feeds so you can utilize Volumill more effectively. These simulations are both Volumill operations using the same tool to cut the same material. As you can see, the operation on the right is feeding faster along the toolpath lines through lighter stepovers. But also notice that the rate of material removal is nearly identical. Faster speeds and feeds is not the real goal in rough milling. High efficiency milling is what we're really after. And this is achieved by combining both high speed and volumetric milling to maximize material removal rate. We'll go over more details about high speed milling, volumetric milling, and milling mechanics in the video presentations that follow this one. Thank you for watching this edition of Science-Based Toolpaths from Celerative University. Be sure to check out our next video in this series, High Speed Milling.